Great. You have pen and paper?
Yes, sir.
Great. Yeah. So Mahendra Singh, welcome. Can you please introduce yourself?
Myself, my name is Singh. I am from Gwalior, Madhya Pradesh, sir. I have completed my Bachelor's of Engineering in 2019 from Sri Govardhan Singh Institute of Science and Technology, Indore. Before this, I have done my diploma in engineering, mechanical engineering, and before this, I have completed my 10th from Sri Government Boys Higher Secondary School, Lahad district. Currently, I am working, sir, and I joined Masters of Engineering, but I'm not completed after my BTech.
Yeah.
My
So
hobby is playing cricket, sir.
yeah, great. So what are you exactly doing right now?
Working, sir, currently working.
Yeah, working where?
Sir, this video is uploaded in lecture, na, sir.
Yes.
So I am working in some public sector, sir, but I'm not disclosing because some restriction is there.
Okay.
So you
Okay.
already know. So I'm not
Totally.
informing to my HR. So
Okay.
please, I request you after selection you upload video.
Yeah, don't worry. We'll discuss it later. Don't worry. Okay.
Uh,
Yeah. So
okay,
you
sir.
said that you joined MTech and then left it. Like, how was it?
Yes, sir. Before my MTech completion, my offer letter is came, so I joined in company.
Okay. Great. Great. Yeah. So Mahendra, why do you want to join BRC?
VRC, sir, my interest is only because currently my profile is not a technical profile till now. Sir, I am working only with purchase department, so I interest in only research area like thermal and more technical works I need, sir, not non-technical works.
Okay. Great. Yeah.
So
So
I am
definitely
thinking
in
only for
yeah. So definitely in BRC we have technical profile mostly. That too definitely the technical officer post. They have works in lab and those kind of thing. Yeah. So what are your most commendable subjects or most favorite subject, Mahendra?
sir. Actually, I am preparing in just three subjects, sir. And because working very less time, so I prepare only three subjects:
Yeah.
strength of basic thermodynamics, sir,
Mm.
strength of materials, and fluid mechanics, and REC, sir, refrigeration air conditioning.
Okay. So like, do you really think, just with these many subjects, one could be a good mechanical engineer?
No, sir, just actually time is very less, so I prepare verbally, but I try my best, sir.
Okay, great. Yeah. So what is viscosity?
Viscosity, the internal resistance force was actually I talk in Hindi, sir, no problem, na? Mix Hindi English bilanguage.
Yeah, fine, fine. Go ahead, please.
Viscosity is internal resistance force developed by the fluid layers, one and two layers. So the viscosity resists the fluid motions of
Yeah,
two fluid layers.
yeah, correct. So can you give me an example? So, like as you said, viscosity is a resistance. So essentially it's a
Yes,
friction,
sir.
correct? And friction
Correct,
leads
sir.
to correct. Friction lead to energy losses and also,
Opposed to motion, correct, sir.
correct. So it leads to energy losses. So
Hmm.
can you give me an example where, viscosity is necessary, it is actively needed?
Actively needed, sir.
Yes.
And sir, the lubrication, any lubrications, for example, grease for bearings lubrication, so viscosity is required.
We need viscosity in lubrication. Why?
No, no, sir, not viscosity, sir.
I asked, give me some example where we need viscosity.
Uh, okay, sir.
Okay, give me an example where we need friction. Now we are not talking about fluid. Give me an example where we need friction.
Okay. इफ सर जनरली अपने को चलने के लिए भी फ्रिक्शन चाहिए होता है
Correct,
मूवमेंट आल्सो फ्रिक्शन इज रिक्वायर्ड
correct.
एंड एंड
Yeah, you're
एवरी
right.
व्हीकल से हैव फ्रिक्शन सर
Correct. So in a vehicle has tires and those tires are
विदाउट
essentially,
फ्रिक्शन इज नॉट पॉसिबिलिटी our existence also is friction without friction is not possible no, sir.
yes, I mean, try to be very, specific when you say something. Don't be like our existence is because of friction and all. Be specific. For example, in vehicle, the tires are exerting friction on the road and vice versa.
sir, correct.
Correct. So now the question is, can you give me an example for fluid where viscosity is needed?
Viscosity needed, sir. I'm not remembering, sir.
Okay, fine. So I mean, a little higher level example, there are some type of fluid coupling. Have you heard of fluid coupling?
Correct, sir. Fluid coupling.
Fluid coupling.
Uh,
What are fluid coupling and how does they work? How do they work?
Transfer the motion, sir, one soft to another soft.
Yes, and how do they transfer?
How do they transfer, sir? Simply, sir, drive and soft, driven soft. Now.
Yes, the fluid coupling,
In line without killage.
correct, correct. So, in between the two shafts, they have fluid in between.
Okay.
And essentially, one
Yes,
rotates and
sir.
that rotates the fluid, and due to the viscosity, it rotates the another shaft. Did you
Correct, sir.
understand it?
Uh,
Okay.
but killage is okay, sir. Correct, correct.
Yeah, see, it has its own application. It's not used everywhere. It's used
Mm.
where, you need a little bit
Okay.
of mm, slow type of power transmission. You want to absorb all type of ups and down and vibration, those kind of things. Yeah. Anyway, so you said you like thermo. What is zeroth law of thermodynamics? Okay, don't tell me the statement. Where do we use zeroth law of thermodynamics?
Sir, making thermometer, sir.
Yeah, correct. Now, can you state the second law of thermodynamics?
Sir, two is in second law of thermodynamics, two statement is there. First, a Clausius statement. Clausius statement tells and ऐसा कोई भी मशीन पॉसिबल नहीं है जो सिंगल सोर्स से हीट लेके फुली कन्वर्ट टू वर्क विदाउट रिजेक्शन ऑफ हीट नॉट पॉसिबल टू क्रिएट एनी साइक्लिक डिवाइस फर्स्ट स्टेटमेंट ऑफ हीट इंजन
Okay. And there
टेक
is
हीट इन
some
वन सोर्स टर्न कन्वर्ट टू हाँ सर
correct. And
एंड
then there is
सेकंड
I am aware of
सर
the statements here. So I mean, I'll skip that. So point is, are these two separate statements or these are same?
सेपरेट सर सेपरेट
So these are different
बहुत
statements.
आर हाँ सर
Yeah, these are different. Does they mean same thing or they mean different thing?
डिफरेंट थिंग सर
Okay, great. Then why we don't have, second law as first statement and third law as second statement, something like that?
थर्ड लो सर
You said that both the statement mean different things, right?
हाँ
Yeah, then I mean, okay, see that you are little wrong here. So essentially, both the statement mean the same thing. They are essentially equivalent statement. Their language could be different, their terminologies could be different, but both of those are same statements. Okay, like, are you
ओके
confused?
सर आई हैव नॉट स्टडी ऑफ दिस बहुत कुछ
Okay, yeah, that's
है
actually pretty basic. I am
यस
I
सर
am yet to even enter into uh, anything a numerical side or some derivation side, anything like that. Yeah. Anyway, so what is can you give me a statement of second law in terms of entropy?
हाँ सर इन टर्म्स ऑफ एंट्रोपी ना सर
Yes,
टू
please.
statement is there for one is cycle for second is process integration dqyt is less than equal to zero first statements this one sir can I draw sir can I
Yeah,
write
please, please, please,
dqyt is less than
please,
equal to
please.
zero first is cyclic process sir second dq is ds is less than sir
What?
so cyclic process for cycles d integration dqyt is less than equal to zero two processes for reversible process के लिए integration dqyt equal to zero and irreversible के लिए sir integration dqyt is less than zero this is for cycle sir for process ds is less than equal to dqyt
Right. So this is essentially the
एक second
Clausius
sir
inequality, right?
हाँ Clausius inequality correct sir.
Correct, correct. So, see, actually, the basis is Clausius inequality, and from there, we kind of derive the second law. Okay. So, here is a
Correct,
question
sir.
for you. Okay, let's say, the refrigerator we have at home. It essentially perform the refrigeration cycle. Can you explain a little bit about the cycle?
Okay. Yes, sir. Refrigeration cycle. Refrigeration cycle is working on principle of vapor compression refrigeration system, sir.
Right. What are the process in vapor compression refrigeration cycle?
Vapor compression, sir, in four component is there. One is compressor, condenser, evaporator, and expansion valve. And two isentropic, two constant pressure process there. One isentropic compression. Second is constant enthalpy process is there. So four process there. Firstly, sir, compress our refrigerant one to two in compressor, then condenser, then expansion valve reducing the pressure, and in evaporator absorbing heat, then extracted
Okay. Right.
heat.
Right. Right.
So this
So,
simple cycle, sir.
yeah. Can you dot TS diagram of vapor compression refrigeration cycle?
Yes, sir.
Yeah. Please draw it. No, it's not clearly visible.
DT is not clear, sir.
No, no, not yet.
This one, sir. Clear, sir.
नहीं यार अभी भी नहीं कुछ भी नहीं दिखा रहा है ओके I'll I'll write here for you.
I don't know, sir. My camera is not.
Yeah. So what is your first process in the cycle? Okay, okay. Let it be. I understood it. That is good. Yeah. So you have condenser in vapor compression refrigeration cycle, right?
Yes, sir.
What is the function of condenser there?
Sir, condenser function is the condenser take heats of vapors, then convert to vapor into liquids, and heat remove the atmosphere.
Correct. Now imagine there is a fridge, a same fridge, and I have placed it in two different locations. One
Okay.
is in, let's say, where are you from? From MP, right?
MP, sir, Korean.
Yeah. So I put it Gwalior. Yeah, I put it in Gwalior, and another one I put it in some hill station, like let's say Simla or Srinagar, something like that.
Okay.
Okay. So at which location will the refrigeration cycle will be more efficient?
8 seconds, sir.
And as a basis, I want to generate, same refrigeration effect.
Sir, similar, sir. Because TL is more. So COP is more.
What is more?
TL, sir. Evaporator temperature is more, sir.
Evaporator temperature is more. More than what? I mean, you are not clear actually.
sir, as compared to high temperature, sir, TL temperature is more. मतलब sir, like as compared to winter, summer to winter में is more ना sir.
I am not talking about summer. I am talking about, okay, one is hot place, one is cool place. Chalo, ye le lo.
हाँ sir.
Where will the freeze or refrigerator work more efficiently? That's my question.
Sir, in cool place, sir.
Wh-
Refrigerator work is more cool place, sir. More
Why,
efficient in
why,
cool place, sir.
why?
Reason, sir, actually, evaporator temperature is more as compared to hot place, sir.
Why evaporator temperature comes into picture? Okay, let's say if evaporator temperature is same at both the location. See, where is evaporator in fridge exactly?
Sir, inside of
Correct. I mean the place
system.
which we want to cool. Let's say at both the locations, I want to cool the place at 0 degrees Celsius only. Both has same
Okay,
evaporator temperature. Evaporator temperature is not changing. It's the
okay,
atmospheric temperature that is changing.
okay. I'm not understand, sir. I'm not remembering, sir.
Okay, okay, fine. Uh, okay, yeah, another question. Okay, Rankine cycle?
Yes, sir.
Correct, great. Now, same question. There is a power plant. Let's say you are an engineer, you are a BRC
Mm,
engineer, for example, and how exactly nuclear power plant works are. They essentially in the nuclear energy is we obtain nuclear energy, we boil steam, and the same steam is then circulated in Rankine cycle. So that's how the whole power plant work. So here is a question for you as a as a technical officer. Let's say you have ample amount of resources, no restriction, and you want to generate
okay,
same amount of power from the power plant. Which power plant will be more
okay.
efficient? The one in Shimla or the one in uh, let's say MP Gwalior. Yeah. And obviously, with every question, there is a why.
Correct, sir. In Gwalior, sir, maybe
Yeah.
steam
Now,
Rankine power cycle, maybe, sir.
see, both are Rankine only. Okay.
Both are Rankine only.
Yeah, obviously, both are Rankine. It's a steam power plant.
Okay.
It's a Rankine cycle.
एक्चुअली सर एफिशिएंट तो न्यूक्लियर पावर प्लांट रहेगा बट
Both
सम
are nuclear power plant. Both are Rankine. Both are steam power plant.
ओके तो इन ग्वालियर सर इज एफिशिएंट इन ग्वालियर
Yeah. Why?
इफ यूजिंग इन सर इन शिमला ना सो मॉइस्चर कंटेंट इज मोर इन एटमॉस्फेयर
Yeah. And how does that affect?
so maybe if you burning the our fuse na take more energy compared to Gwalior place because in Gwalior is place is dry temperature like 30 normal temperature 20 30 35 but in Simla temperature is less than so maybe this is possible sir.
No, your even explanation isn't that accurate. See, we are boiling through nuclear energy. Okay, you don't need to care about that. I'm asking which power plant will have a higher efficiency, the one in Gwalior or the one in Shimla?
High efficiency sir Gwalior sir
Okay, so uh, as an answer, the one in Shimla will be of higher efficiency. Reason being, the only difference is the condenser temperature. Let's say you want to vent out same amount of energy. What essentially the condenser does?
heat rejection sir
Correct, heat rejection. Now, for heat rejection, you need a temperature difference, right?
correct
Correct. Now,
latent heat
latent heat temperature
Mm.
or and
No, no, sir.
for that heat
Correct, sir.
rejection, you need a temperature difference between your working fluid, which is steam, and the atmosphere, right?
Okay.
Okay, now where will have a higher temperature difference for heat rejection?
Simla, sir.
Similar, yes. You understood now?
Yes, sir.
So the power plant in colder region usually, are more efficient, but obviously it's not, geographically, and there are other factors, but yeah, as a hypothetical situation, uh, also, the efficiency of any cycle, we can write it as T
Okay.
1 minus T heat rejection by T acceptance or something
It
like that.
supplies.
Okay.
Yes.
T supply, yes.
Okay.
Average. Here the T's are average. Now,
Correct, sir.
which
Mean
the
temperature.
correct mean
Mm.
temperature of heat addition or mean temperature of heat rejection, like that. So rejection by
Okay.
addition. Now, which one will have a higher efficiency? The one who has higher uh, the one who has a lower temperature of heat rejection, right?
Okay. Yes, sir.
Correct. What is formula? 1 minus T mean rejection upon
1
T
minus
mean
T mean.
addition.
Yes, sir.
Correct? Yeah. The one, so lower T rejection will be a higher efficiency.
Okay. Correct, sir. Tree rejection is lower, so overall value this factor of less than very less.
Correct. And
So
where
overall
can
1
you have
minus less, so efficiency is more.
correct? So and
Okay.
where can you have a lower heat rejection temperature at Gwalior or at Shimla?
Similar, sir.
Shimla. Exactly. Exactly. Yeah. So that's the answer actually. Yeah. Uh, just a minute. Uh, what's the time? Yeah. So, Mahindra, what I will do is right now I'll conclude the interview here. Okay. So I'll stop the recording.